Hello and welcome to Problem Solving. Today you're going to need a note sheet from me that you received in class. That's just so you have less to write down, a calculator and a pencil. We are going to go ahead and get started on learning some general problem solving techniques. When we do solve story problems, we have to make a plan. I think that most story problems are very scary for most students. And so if we make a plan, we can really solve any type of story problem that we have. So your plan may include drawing a picture, a visual representation, or a geometric model is always a good place to start. If you can't draw a picture, maybe you can write a verbal model talking about the words and what's happening using abbreviations. You might even use a pattern. But with any case of what you decide to do, from that picture or pattern or verbal model, we can then take and create an algebraic model, which will include variables. And once we have that algebraic model, our job is to solve that algebraic model, to find the answer, and to check to see if it's correct. So today we're going to talk about a couple of different types of story problems, and I'm going to show you these different techniques to use in solving them. So let's start off by talking about a high-speed train that is traveling between Boston and Washington, a distance of 457 miles. The trip takes 6.5 hours. What is the average speed? Well, you may already know that there is a formula that we can use when we are working with distance and time and rate, and that is distance equals rate times time. We plug in the 457 in for the distance, r in for the rate, and the 6.5 hours in for the time. And so we have an equation of 457 equals r times 6.5. To solve for that r, we would divide both sides by 6.5, and we would approximately get 70.3. So the question is asking, what is the average speed? So we would write that the average speed of the train is about 70 miles per hour. It's really important that we include units in our story problems. And the units here would be miles per hour. Okay, let's try another one, except for this one is aviation. So a jet flies at an average speed of 540 miles per hour. How long will it take to fly from New York to Tokyo? A distance of 6,760 miles. So I already gave you the answer here. We would get 12.5 hours, but how would we do that? We would set up the formula distance equals rate times time, and in that we would also go ahead and fill in what is the distance, 6,760 equals the rate of 540 times time, divide both sides by 540, and you would get a time of 12.5 hours. So those are two examples with using a formula. Let's talk about an example that we could use that would use or look for a pattern. Sometimes this is very helpful in predicting after so many times. So we have a paramotorist. A paramotor is a parachute propelled by a fan-like motor, and the table shows that the height h of the paramotorist t minutes after beginning its descent. Find the height of the paramotorist after 7 minutes. So you can see before the paramotorist has even started, he had an initial height of 2,000. And so he was descending or decreasing in height after each minute. And if we look at that pattern and take it out of the table, you can see that he is actually decreasing at 250 feet per minute. And you can see that by looking at the numbers 2000, 1750, 1500, etc. And from there, we can set up a word equation before we get the variable equation. So the question was asking to find the height of the parachute after 7 minutes. Well, we have to first know what we're looking for, and that would be we are trying to find the height after so many minutes. So we're going to start with his initial height and subtract how much he's descending per minute times however many minutes he is traveling. And then you can see that the variable equation underneath of it would be h equals 2000 minus 250 times time. And so our equation, h equals 2000 minus 250t, when the question originally asked us to find the height after 7 minutes. So what we could do is plug in 7 in for time. And if we did that, we would get 250 feet. Now you're probably thinking we could just continue this pattern and decrease it by 250 and we would get 750 and we would continue on to 500 until we eventually got 250 feet. And that might be okay if it's only 7 minutes, but what if it was 27 minutes or 70 minutes? By continuing that pattern, that would not be the most efficient way to solve the problem. So using the formula or finding an equation and using that equation is truly the fastest method. Okay, here's example number 4 where we are going to draw a diagram. You are hanging 4 championship banners on a wall in your school's gym. The banners are 8 feet wide and the wall is 62 feet long. There should be an equal amount of space between the ends of the wall and the banners and between each banner. How far apart should the banners be placed? Well, if we draw a model, we can see that we have 62 feet to work with. We have 4 banners, each of 8 feet long, and we want equal spacing in between each banner. So now that we have a picture, we can set up our algebraic model, which would be x plus 8 plus x plus 8 plus x plus 8 plus x plus 8 plus x. So we've got 4 banners, 8 long, and we have 5 spaces in between every single banner of all equal lengths. We combine like terms. We get 5x plus 32 equals 62. Subtract 32 on both sides. Divide by 5, and you get x is equal to 6. Well, what does that mean? It means that we want to space each one of the banners 6 feet apart. Okay, let's try another example. We have another paramotorist. In this we have a table or a pattern that shows the height of the paramotorist after t minutes. This time we want to find out what the height of the paramotorist is after 8 minutes. I do not want to continue my table for 8 times. So we're going to look at the pattern at what's happening here. His initial was 2,400 feet. And every single time he descended a minute, he went down 210 feet. So we know that we are looking for the height of the paramotorist after the initial, we have an initial amount minus every 210 feet per minute, and for the minute we're going to use t as in time. So then with this we can plug in our 8 for time and we will get 720 feet. So I've given you some examples using patterns, making a diagram, or using word algebraic modeling with words to solve story problems. And if we develop a plan and use that plan, it can be very simple to solve these problems so that you're not afraid of them. Now you can go ahead and put your notes, tape them down in your notebook, and that will be all. Thank you.